Hello guys, we are back with another video. Today we are seeing another question of the bit manipulation section. That is, so we are taking another question. That is, we have been given a number and we have to check whether it is a power of two or not. So here we require a number from the user. That's what we have done over here. We have taken the number from the user and now we are checking whether it is a power of two or not. So there are two approaches. First is the naive approach and another one is the efficient approach. So let me first explain you the naive approach. Then after we will go with the efficient approach. So let me first implement this, then I will explain it to you. Okay. So first is if n would equal to 0, return false, as I have taken the return type as bool. Else while n not equal to 1, if n modulus 2, if it is not equal to 0, I will return false and do the n equal to n by 2 and then I will return true. Okay. Else what I will do. So this is the code which will which will tell us whether a given number is a power of 2 or not. So let's see how this code is working. So suppose if we are given a number 4 from the user, so here we will get 4 as a number. Now n is equal to, because this is a base condition I have written. For why? Because if a number is 0, because we know that for number 0 it is not a power of 2, because 1 is a power of 2, 2 is a power of 2, 4 is a power of 2, 8 is a power of 2. So that's why I've written the base condition. If n is equal to 0, then simply return false. Then I have written while 4 is not equal to 1. So it will go into this while loop because 4 is not equal to 1. Then it will check for this if condition that 4 modulus 2. If it is not equal to 0, then return false. Otherwise, divide this 4 by 2. Now we get 4n as 2. Again, what we will do, 2 is not equal to 1. Then again we will do 2 is not equal to 2. So 2 modulus 2 is not equal to 0, but it is equal to 0, so it will not go into the if condition, and our 2 will get divided by 2. Now we get n as 1, so it will come out of this while loop and we get return as true. So yes, we can say that 4 is a power of 2. So similarly for 6, if you take a number 6 is it equal to 0? No, so it will not go into this if condition. Though 6 is not equal to 1, so it will go into this while loop. Now it will check if 6 modulus 2 is it not equal to 0. So we say that no, it is equal to 0. So we will divide this number again by 2. So we get n as 3. Now 3 is not equal to 1. It will again enter this into this while loop. Now 3 modulus 2 is it not equal to 0? No, because 3 modulus 2, the remainder is 1, so it is not equal to 0, so we'll return simply false because 6 is not a power of 2. That's why we have returned false. So let's check whether, so let's first we'll complete this code. If naive of n, if it is equal to true, what I will return, I will print it is a power of 2, else I will print not a power of 2. Okay, understood? Let's run this code. Let me first clear this terminal for you. Now I will again run this code. So for 6, we have seen that it is not a power of 2. Let's see whether it is giving us the right output or not. 6, so not a power of 2. Let's see for 8. Yes, it is a power of 2. So we see that our logic is correct. Okay, so this was one of the approach, that is naive approach, but the time complexity of this naive approach is big O of n. So we will see another efficient approach. So another efficient approach that we are going to say is the same approach or the same logic or the algorithm which we have seen in our previous video, that is of Brine-Kernighan's algorithm, where we will be using the Brine-Kernighan's algorithm. I will explain you how. Because if you are not aware of Brine-Kernighan's algorithm, I have explained it in the previous video, so you can watch that video first, and after you can come over this video. So it would be easier for you to understand. So what I have written, if n and n minus 1, if it is equal to 0, then what do I have to do? I have to simply print yes, it is a power of 2. I will explain you how this code is working. Let me first complete this code. No. Okay. So We call this function check power 2 for n. Okay, so how this code is working is that suppose if we are given a number 4 and we are doing what we are doing is we are checking in the if condition if n that is 4 and we are performing AND operation with 3. What is 4? 4 we know that it is 1 0 0 and what is 3 we know that it is 0 1 1. If we do the AND of these two, we what we will get, we know that for AND operation if both the bits are 1 then only the output will be 1, otherwise it will be 0, and we know that it is 0, so it will simply print yes it is a power of 2. This is a simple logic that we would use over here. So let's run this code and check whether we are getting the right output from multiple test cases or not. So let's give input as 6. So no, we have seen this in our previous logic in the naive logic that 6 is not a power of 2, so that's why it is giving us no other output. So for 8, yes it is a power of 2. So for 16, yes it is a power of 2. Let's see for 20, no it is not a power of 2. So this is the efficient approach and it takes big O of 1 time. So this is how we implement our code for checking whether it number is power of 2 or not. So I hope you understood this question. So thank you.